Hi, this is Professor Stugard, and in this video we're going to talk about what to do when your data is missing. So missing data is a fairly common problem when doing data analysis or data science. And so in this video we're going to discuss what missing data looks like and then how to deal with missing data. So again, like I said, missing data or improperly entered data are very, very common frustrations when working with data sets. Now, in R, missing values are represented by NA, which means not available. So anytime you see NA, that typically means that the data is missing. And the nice part about using RStudio as well is that many times it will also put the missing data in red when you're in your console to kind of make it more obvious that that data is missing. There are other types of data that cannot be worked with also. We call those impossible values. Now again, this typically happens when we have functions defining different variables in our data frame. For example, we use the mutate function and we accidentally divided a value by 0. That doesn't mean it's missing, but it's not actually a number, and that would be NaN for not a number. Now, a lot of times also, and we're not going to cover that too much in this video, when people enter data, it's missing, but somebody entered something in anyway for some reason. And many times these data points would look like outliers. So they were typing in like the weights of a bunch of people. They said, well, I don't know what the person's weight is, so they typed in a 0. Well, a 0 is definitely worse than typing in nothing, because when you take an average, you're not going to notice that that missing data is actually a 0 till later, but it happens pretty frequently. But again, by arranging data, you can usually take care of those issues. All right. So let's get into the actual R commands for our missing data. So the most commonly used one, just to tell if data is missing, is our function is.na. And again, that's pretty straightforward. When we use the is.na function, it returns a logical value. That means it must be either true or false. And it's going to return a true when the data is missing. So if the data is represented by an NA, or the missing data is represented by NA, and you use that function, it will return true. Now the nice part is you can actually use this on vectors, lists, matrices, data frames. It's pretty universal. So here's how we would use it. Let's say I have a vector X filled with values. All right, so I have my vector of values, and the values in this vector would be 1, then missing data, 3, and then missing data. When I run my is.na function on this vector, it's going to go through term by term and determine whether or not each entry is missing one at a time. So when I execute this code in my console, it's going to return false, true, false, true. Because, well, it asks, is the data missing? Well, for the first entry, we have the number 1. It's not missing. It's false. However, my second entry, it is missing, which means that it's true that the data is missing, so it returns the value true. 3 obviously exists, so it's false, and then my last entry was NA, so again, we return the true value again, because is it missing? True. Yes, it is missing. Now, when we have data frames, we can actually use the same exact function, and it will run through our data frame and tell us true, false. But typically in a data frame, that's not always necessarily the best way to do things, because it can be, well, kind of unwieldy to look at the entire thing anyway, because usually our data frames are pretty big. So one thing that we can use too is figure out, well, how many entries are missing in our data frame. And for that, we can use the SumIsNA function. The reason we can do the sum function is because the way R works is that the logicals for true and false, well, R also recognizes those as 1s and 0s, kind of that binary. Goes back to the whole concept of Boolean algebra that we actually developed all of computer science from, that things are either on or off, 1s or 0s, true or false. And so every time it comes up with a true value, R also recognizes that as the number 1. So you can sum up every true value as basically summing up a bunch of 1s. And it'll tell you exactly how many entries are missing data. Now, the nice part is you can actually use this on your entire data frame as well by using the column sum function. So COL, then capital SUM. Again, that kind of snake case for a lot of our older R functions that have existed for decades. And then it'll go through each column one at a time. So let's take a look at this as in a data frame. So let's say I have a data frame called just df. Variable 1, variable 2, again, this is pretty straightforward. Variable 1 has entries 1, 2, 3, and then the last observation is missing. Variable 2, we have missing data, then 4.2, missing data, and 3.2. So again, pretty simple, small data frame that we're looking at here. If I want to figure out how much missing data is actually in my data frame, I'm going to use my column sums function. Inside my column sums function, I use the is.na, because again, that'll return my true or falses. I tell it to run on my entire data frame. So it's going to turn everything into true or false in my data frame, whether or not it's missing. And then it'll add those numbers up for each column or each variable. And there we go. Variable 1 has 1 missing data point, and variable 2 has 2 missing data points, which is exactly what we expected to happen. And we can tell, again, how much data is missing. And again, this is really important because sometimes we're like, well, let's do analysis, but when a bunch of the data is missing, if you have more missing data than data that exists, well, maybe that's not a very good variable to do analysis with. All right, so how do we get rid of our missing data? Now, there are several ways to do this, and we're going to talk about a couple different scenarios here. But the easiest way to ignore missing data is, well, in our functions at least, is to include this argument. So again, an argument is part of a function, something that we put inside the parentheses, but we would put this at the end separated with a comma, and it is na.rm, and we would set that equal to true. So rm is a function that removes objects, rm for remove. So when I have na.rm, it says remove the NAs. But again, we have to set that argument to either true or false. We have to tell basically my function, do I want to remove all of the missing data or not? So again, let's take a look. So we have my vector from earlier, right? My vector is 1, missing data, 3, missing data. And if I try to find the average of my vector, if I say, okay, find the mean, find the average of these numbers, it's going to return NA because it can't do it. It's missing data. How do you average something that's missing? However, if I say find the average, but now I include that argument, which means put a comma and then include that whole little block, na.rm equals true, now it will average everything that is not missing. So what's the average of 1 and 3? 2. And that's what R will return for us. And the nice part is this leaves our original vector unchanged. It just tells us for this one function, just this one time, ignore the missing values, but leave everything the same. That's not always how we want to go about doing things, though. If I want to take my data frame and remove every single observation, that means every single row that has missing data, the most common function that we would use nowadays is the drop_NA. This is a tidyverse function. And again, typically you can tell if it has an underscore, it's a newer function that is designed to work with tidyverse and designed to work with our wrangling functions that we've done before. And the nice part is when we use the drop_NA function on my data frame, again, we plug in a data frame, it's going to return another data frame. This time just with all the missing data gone. Now, if I run my drop_NA function on this, so drop_NA, and I'm going to plug in my data frame here at df. You could also use the piping function as well, so you could pipe df into the drop_NA. Well, it's going to go through line by line, so row by row, and any row that has any missing data for any one of the variables, it's going to get rid of. It's going to drop it. So in this case, we end up with just row 2. Row 2 is the only row that gets returned for my drop_NA because it goes through and it says, all right, look at row 1. Uh-oh, there's missing data for variable 2. Get rid of it. Line 2, oh, no missing data, so that's fine. Line 3, oh, missing data for variable 2 again. Get rid of it. And row 4, oh, missing data for variable 1. Get rid of it. So again, it's only going to leave rows that have every piece of data filled in. Now, another convenient way that we can remove observations when data is missing is to use the filter function. And the nice part about this is this can go column by column or variable by variable. So we can pick exactly which variable we want to get rid of the missing data and not necessarily get rid of every single row that has missing data. And again, when you deal with big data frames that have dozens of variables and hundreds of observations, again, you're typically looking at just one or two variables at a time, so you don't want to get rid of everything just because one variable is missing some data somewhere. So we use our filter function. So if I use filter and then my exclamation point. Now remember, the exclamation point is our negation object in R. So it's basically like the word not. It tells us to do the opposite. So when we use our is.na function, and again, that's telling me, is it NA, is it missing, true or false? Well, what we wanted to do in this case is, remember, the filter function takes those logical arguments and only preserves it when it's true. But the is NA would say it's true when it's missing. But I don't want the missing data. I want the data that exists. I want the non-missing data. So that's why we need to include that exclamation point, because the exclamation point will make sure that we're preserving everything that is not NA. And again, that's kind of how we would read the inside of that function. Filter my data frame and preserve everything that is not missing, that is not NA. So let's go back to that same data frame. Again, we have two variables, 4 observations. And if I take my data frame and I pipe it into my filter function, and I use my is.na, or I should say not is.na, and I do it for variable 2, now it's going to go through my data frame, and it's going to say, well, let's see, we go row by row, and in this case, I'm going to have 2 entries left over. And again, see how even though there's an NA in variable 1, doesn't matter. I still got to preserve that data because, again, maybe I'm only concerned with variable 2 right now. That's the only variable that I'm actually really investigating. And it's the same idea. Again, it goes row by row. Get rid of the first row because it's an NA in variable 2. Second row is good. Third row, variable 2 is an NA. Get rid of it. Fourth row, there's missing data somewhere, but it's not in variable 2, so we can still preserve it. Now, when we do have missing data, again, sometimes we remove it, sometimes we want to replace it. Now, which is the best choice? All right, that's dependent on the situation. There's no one right answer for this. So again, spending time practicing doing data science and again, just playing around and doing your analysis will definitely help you determine which is the best solution. But if you do decide that we should replace the missing data, typically we choose to replace it with the center from the remaining data. And again, that way we don't just get rid of the entire observation. We say, all right, well, it's missing, but all right, it's probably what the average would have been anyway. And that way it doesn't change what that center would be. It would still be the same average just because we're adding in what the average would be as an extra observation. And again, it allows us to retain all of our observations. Now, the important thing to note is that whether you remove missing data or you replace missing data, you always want to make sure that you make a note of that. And not just like a small little note in the comments. You should really make sure that that is a very well understood part of your report or your project that, hey, here's this data, I want to remove it or I want to replace it. So that you make sure that, again, your professional looking reports are as well. We want to make sure that someone could not be misled. We don't want anyone claiming that, hey, he removed a bunch of data. We can't trust what he did anymore. Well, no, I told you up front that I removed the data, and here's why, and everything else. So again, always make sure that you note exactly what you're doing when you are doing your projects and making your R markdown files. So how do we replace missing data? This one's a little bit more complicated, and if you don't get this at first, that's okay. But let's go back to my vector x. So again, my vector x has the values 1, missing data, 3, missing data. The code I'm going to use here is this. So we're going to look at this part by part. So the first piece, this x, and then when I use my square brackets, my square brackets subset my vector, or even my data frame sometimes. But basically it subsets it or indexes it, which means it goes by element. We can choose elements as we go through that we want to actually look at. And again, we can actually go through and say, hey, I only want the first element, and put the number 1 in those square brackets, and it's only going to return the first one. In this case, we're saying, look through the vector, and all I want is the values that have missing data, that has the is.na. All right? So again, that's what that bracket does. The bracket basically says, go through the vector element by element. And again, what you type into those brackets changes really what you're looking at. So then the second part is, well, what do I want to do? So we have our arrow, which is how we store things. So basically, I want to replace all of those entries where the data is missing, and I want to replace it with the average from the data that's there. And again, you'll notice that mean x comma na.rm equals true. That's the same function that we looked at a little bit earlier in this video. And when I do that now, and I look at my vector x, oh look, it removed my missing values and replaced them with the value 2. So now the average of this vector is still going to be 2. It didn't change the actual average of these values, but now we have well, the average instead of the missing data. And again, it's just something you would make sure that you always note that you did if you do it. But again, it can be very convenient to help preserve large data sets and not just get rid of everything. And again, which scenario should you use which case? Well, it depends on the data set and what you're doing. All right, so that wraps up what we're going to talk about with missing data. So can you answer the following questions? Number 1, what does missing data look like? Number 2, how do we omit missing data entries in functions, right? What is that argument? What argument allows me to omit the missing data entries? And then number 3, how can I remove all observations with missing data? Now, remember, there's more than one way that we can do this. So see if you can find or remember those multiple ways. And if you can't, remember, go back and watch the video. Make sure you take notes. Good luck, and as always, take care of yourselves.